June 11, 1997, Salt Lake City. Michael Jordan was curled up in a hotel room, barely able to stand, reportedly after eating pizza delivered to his room the night before. His trainer, Tim Grover, looked at him that morning and thought there was no realistic chance he was playing. Jordan played anyway, scored 38 points across 44 minutes, hit the go-ahead three-pointer with 25 seconds left, and then folded into Scottie Pippen's arms the moment the pressure lifted. Afterward, he told reporters he had almost played himself into passing out. Phil Jackson, coaching from the sideline, would later describe it as one of the most remarkable things he'd ever witnessed in basketball. What nobody quite has an answer for is this. Jordan didn't perform adequately despite being physically wrecked. By most accounts, he played one of the most precise, controlled games of his career. And that should bother anyone who takes performance science seriously, because it doesn't fit the story we usually tell about optimal conditions, ideal preparation, and peak physical state. So what was actually happening in his brain, and can it be understood? Or was it simply Jordan being Jordan? The concept researchers reach for most often in moments like that one is flow. Complete absorption in a task, where effort stops feeling like effort, where time compresses or stretches unpredictably, and where the constant background noise of self-evaluation goes quiet. The psychologist Csikszentmihalyi formalized the idea in 1975 and spent years mapping the conditions that seemed to produce it. The right balance between challenge and skill, clear goals, immediate feedback. His experience sampling studies, conducted using what is now formally called the Experience Sampling Method, ESM, where participants reported their mental state throughout the day via a beeper, produced a genuinely strange result. People reported more flow at work than during leisure, and yet simultaneously wished they were somewhere else. Flow, it turns out, doesn't feel pleasant while it's happening. It just tends to produce better results, which tells you something about what the brain is actually optimizing for when performance peaks. The most widely cited explanation is called the Transient Hypofrontality Hypothesis, proposed by neuroscientist Arne Dietrich in 2003. The core idea is that during intense physical or cognitive engagement, the prefrontal cortex, and specifically the dorsolateral prefrontal cortex, or DLPFC, which handles self-monitoring, inner narration, and second-guessing, loses bandwidth. Not entirely, but enough. The voice that asks whether you are doing this right, whether the last decision was wrong, whether people are watching and judging, it quiets down. And the brain regions responsible for trained, automatic movement and pattern recognition get more of the available resources. Related to this is what neuroscientists call the default mode network, or DMN, the brain's task negative system associated with self-referential thought and mind-wandering. When the DMN goes quiet, the internal commentary tends to go with it. The self gets out of the way and the skill takes over. A 2008 brain imaging study from Johns Hopkins by researchers Charles Lim and Alan Braun found something consistent with that picture. Jazz musicians improvising inside a scanner showed extensive deactivation of the dorsolateral prefrontal cortex, alongside a boost in sensorimotor activity. That was a single study with a specific population doing a specific task, and it hasn't been cleanly replicated across different contexts, so it's worth holding with appropriate caution. But the directional signal it points toward has shown up elsewhere. A 2022 systematic review covering 25 neural studies found converging evidence that attention, executive function, and reward-related brain systems are all involved in flow. And a 2024 study from Drexel University using EEG recordings with jazz musicians suggested that creative flow involves two distinct factors: extensive prior experience building specialized brain networks, followed by a kind of optimized processing efficiency once those networks are deeply established. The brain stops spending energy supervising the task and simply runs it. This is roughly the territory Stephen Kotler mapped in his 2014 book The Rise of Superman, where he argued that flow states represent a form of optimal performance accessible through specific environmental and psychological triggers. His work brought this research to a wider audience, though it also drew criticism for outpacing what the controlled evidence could fully support at the time. And that's when the Jordan story becomes genuinely interesting from a neuroscience angle. Severe physical illness tends to reduce certain kinds of cognitive overhead. The internal monitoring, the performance calculation, the awareness of crowd and stakes and consequence. Jordan, by his own account, was too unwell to overthink anything. The prefrontal quieting, particularly in the DLPFC, that researchers associate with flow, may have arrived not through deliberate focus or mental preparation, but through biology, removing the option to do anything else. He couldn't ruminate. He could only play, which is not, to be clear, an argument for deliberately compromising your physical health before high-stakes events. The point is structural. The mechanism researchers believe underlies peak performance, reduced self-referential interference, the DMN stepping back, automatic execution of deeply trained skills, reward and attention systems aligned around the task is not something you switch on through conscious effort. It tends to arrive when certain conditions are met, and one of those conditions, counterintuitively, is that you stop trying to control the experience. Here's where the science asks for some honesty, because popular accounts of flow tend to smooth over the real limitations in the research. A 2021 meta-analysis covering 22 studies found a medium-sized association between flow and task performance, with a pooled effect size of around 0.31. That's a meaningful number, but the same authors concluded that the evidence cannot determine whether flow actually produces better performance or whether people simply label their good performances as flow after the fact. Retrospective self-report is a genuine methodological problem. A great game ends, and you describe yourself as having been in flow, but you weren't measuring your mental state in real time. You were reconstructing it from the outcome. The association could partly be running in reverse. There's also a more recent challenge to one of the field's most frequently cited neural markers. A 2024 preprint analyzing over 700 video gameplay sessions found no reliable theta wave activity accompanying what participants reported as flow states, which directly contradicts earlier EEG findings that had positioned frontal theta as a neural signature of the state. That preprint has not completed peer review yet, and a single dataset does not resolve a scientific debate, but it signals clearly that the neural story of flow is still being written, and that confidence in any single mechanism, whether it is DLPFC deactivation, DMN suppression, or frontal theta, is probably premature. What the research does consistently point toward is a pattern worth taking seriously. Flow states, whatever their precise neural basis, are associated with the suppression of self-monitoring and the dominance of trained, automatic skill execution. That pattern appears across sport, music, creative work, and cognitive tasks. And it is not manufactured through effort. It tends to emerge when effort is no longer required to manage the fundamentals, when a skill is so deeply embedded that the brain can stop supervising it and simply run it at full capacity. Jordan had been running those basketball skills for over 2 decades by the time Game 5 arrived. The shooting mechanics, the court geometry, the competitive instinct, all of it was as automatic as walking. What the illness may have stripped away, even unintentionally, was the layer of conscious management, the dorsolateral prefrontal cortex overhead, the default mode network chatter, sitting on top of all of that trained capability. He told reporters afterward that he was amazed he had gotten through the game at all. The research suggests he got through it partly because, for once, he couldn't get in his own way. Flow doesn't announce itself. It doesn't respond to pressure or willpower or the desire to perform. Researchers believe it arrives when the conditions are right, when the skill is deeply enough established, when the self steps back far enough, when the task and the person are matched closely enough that the brain stops treating the whole thing as a problem to be managed. Jordan in that hotel room had no choice but to let go of the management. And what came out on the court that night was something closer to pure execution than almost anything else in his career. The science of what flow actually looks like in the brain and whether it can be deliberately induced is the subject of active, ongoing research. One specific question receiving serious attention right now is why elite athletes so consistently describe time slowing down during peak moments, and whether that perceptual distortion is a cause of optimal performance, a consequence of it, or simply a byproduct of the same neural conditions that produce both. If the gap between what people commonly assume about peak performance and what the evidence actually shows is the kind of territory that interests you, that's what this channel tracks.